Yo, 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 this is Mr. O. Yo, 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 this is Mr. O. And today we're going to learn about inductive reasoning and conjecture. And together with finding counterexample if we need to. Okay. So, what is inductive reasoning? For example, I give you 2, 5, 8. How would you know the next three numbers? Before you give me the answer, what you're doing now is inductive reasoning. You're trying to make a conclusion based on your observation and pattern. So inductive reasoning is making a conclusion based on observation and pattern. So right now we have 2, 5, 8. We're trying to get the next few numbers. So what are we doing? Before we come with the conclusion, we're trying to observe the given 2, 5, 8 and find the pattern here. And we know the pattern is we're adding 3. So therefore this will be 11, 14, and 17. And therefore our hypothesis or conclusion here is that we're adding 3 each time, and that is our conjecture. That is our concluding statement. So conjecture is a concluding statement. Concluding statement reach using inductive reasoning. So when we make a statement, a final statement, based on our observation, that is, we're doing a process of inductive reasoning. And our statement is called the conjecture. Okay. So let's find the next few terms here, 5 terms of the sequence, then write a conjecture. For example, I have here number 1, 38, 31, 24, 17. What do you think will be the next 5 terms, and what is happening there? I can observe that 38, 31, 31, 24, 24, 17. I am subtracting here by 7. Subtract 7 from the previous term. So 17 minus 7, it's 10. 10 minus 7 is 3. 3 minus 7 is negative 4. Negative 4 minus 7 is negative 11. And this will be negative 18. And that's how you complete the sequence and make a conjecture. Next. 2, 5, 11, 23. 2 and 5, they're 3. 5 and 11 is 6. 11 is 12. So what's happening here? You can say multiple things. You can say here that you double, you multiply 2. 2 times 2 is 4. You add 1, becomes 5. You multiply 5 by 2, get 10. You add 1, it's 11. You multiply 11 by 2, plus 1, you get 23. So what's happening here? You double, that means it's times 2. You double the previous term. Then we add 1 to get the next term. So the next term will be, we need a calculator here, 23 times 2 plus 1 is 47. Times 2 again, plus 1 will give us 95. Times 2 again, plus 1, it's 191. Times 2 again, plus 1 is 383. Times 2 again, plus 1, it's 767. Very simple, right? 1, 4, 9, 16. I have here, obviously, a perfect square number. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 16 is 4 times 4 is 16. So 5 times 5 is 25. 36, was that 49, 64, 81. These are the perfect square numbers. So for us to get the list there, these are the lists of the perfect square number. Perfect square numbers. Okay. A, D, G, J, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, Q, R, S, T, U, V, W, X, Y. Right there? Yes. So what's happening here? To generate the next term, what do we do? We skip two letters after the previous term. Okay. Next, 7:30, 75, 8:20. The next one will be 8:45, 9:10, 9:35, 10 o'clock, and 10:25. What's happening here? You're adding 25 minutes to the previous term, to the previous term. And that's how you write conjecture and complete the sequence. Let's go now to counter example. What is counter example? Counter example. A counter example is making a statement to prove that conjecture is false. Okay? That your hypothesis or your speculation, your conjecture is false. Let's do this one. Determine whether the conjecture is true or false. If it's false, provide a counterexample. The sum of any two consecutive integer is always add. So two consecutive integer means say the sum of any two consecutive integers is always add. For example, 5 and 6. They're consecutive. When I add them, the answer is 11. If I have 1 and 2, that's going to be 3. If I have 6 and 7, that's going to be 13. I've seen that they're always odds, so I know these are true, so I don't have to provide any counterexample because I cannot come up with any numbers that are consecutive. When I add them, will not be an odd. Next, the product of two numbers is always larger than either number. So, if, for example, the product of two numbers is always larger than either number. You can think that 2 times 3 is 6, 8 times 9 is 72. 6 or 72 will be bigger than its factors. Yes, it's true. But is it always true? The answer is a false conjecture. Why is it false? Because here's my counter example. If I multiply 2 by a half, the answer is 1. Is the product always larger than either of the number? Is 1 bigger than 2? No. Is 1 bigger than 1 half? Yes. Since 1 is not always going to be greater than 2 and 1 to each factor, then this is a false. So this is a good counter example. Vertical angles are never complementary angles. Complementary angles means equal to 90, and vertical angles can be these two angles here. Can they be complementary? The answer is yes. It's going to be false. It can be. It's always can be never. Okay. Sometimes is the answer there. If this is equal to 45, that has to be 45 because complementary angles has to be congruent. And if they're congruent, was 45 plus 45 is equal to 90. Therefore, they're complementary. And that's my counter example. All state names have at least two syllables. Syllables like Virginia, Virginia, or Texas. That's two syllables. But do all USA states, all the states in the United States, names have at least syllables? No. For example, Maine. Maine is only one. Maine. Main is only one syllable, so that's my counterexample. Okay, and that's how you make conjecture and write a counterexample if it's a false conjecture. Kaboom.